All right, so you should have your goal. By the end of this period, we're going to be able to solve a system equation by graphing. So what we're going to do is the other day, we practiced graphing one line. Well, a system is when you have two lines, and wherever they cross is your solution. An example of when a system might be used is, let's just say, you leave your house and you're going at this certain rate per minute, okay? And someone else leaves their house and they go a different rate. That could be a linear function, and wherever they cross is when they're going to be like equal distance. For the example, the question would be, how long does it take for so and so and so and so to be at the same location? So that's an example of the system. In your foldable, the very first, I kind of just went over what a system is. So it's when you have two equations. A system is when you have two equations. Y'all understand? Example 1 is when you have one solution. An example of one solution. And so we're going to do that, but let's go back where it says one solution. You need to, underneath this one solution, put parentheses, like your answer is a coordinate. Wherever the two lines cross, that's one solution. So on here, I'm going to also show you an example like, okay, so you have one line, and then you have another line. Right there's the solution. So draw that on the front tile of yours so you have it. Okay? So one solution is when they cross one time. Questions? We good? Alright, so sometimes, you need me to go back? Okay. So sometimes they're ready for you to graph. You like those. Like, for example, the very first one, it is in slope-intercept form. So you pick where you start, and we said, let's go ahead, I'm going to put my M as something and my B as something. Remember, M stands for what? Slope, but for you guys, what does it stand for? For you guys in the pre-IB, it stands for gradient. Okay. What is my slope? 1/3, and my y-intercept is -3. I'm just writing that just so you can see it. That's what you're supposed to do in your assignment. So if you're going to graph this, your graph starts at -3 on the y-axis. On the y, it's the y-intercept, so it needs to cross at the y-axis. And then from there, your rise is 1, and your run is 3. Rise 1, run 3. Please use your ruler when you draw this line. It is very important that we draw it through these points. What? All right. So once you graph it, make sure you use your ruler. The reason you need your ruler is so that when we draw our other one, if your lines aren't straight and going through the points they're supposed to be going through, it's going to be hard for us to find our solution. Okay. So the first one was in slope-intercept form. All right. The second one is not. And you could put it in slope-intercept form, or you could use intercepts. We don't really know how to use intercepts right now, but I want to kind of just show you how easy it is. So if I cover up this and you solve for x, what does x equal? Yeah, it would be 2. Like if I covered this up and I said, hey, solve for x, you'd say x equals 2. So the x-intercept is 2. And I'm going to show you how this works on the other. I'm just kind of, maybe you get a problem that says something about an intercept. If I cover this one up, the 2x, and I ask you to tell me what y is, what's the y-intercept? 4. Okay, so you see those 2 points right there? Let's see if they match up with my slope-intercept form when I do it. When you go to solve and put it in slope-intercept form, to get y by itself, you're going to move what? Yeah, you're going to move the 2x by, so minus 2x. And you're left with y equals -2x positive 4. Okay? Y'all with me? So your graph is going to start at positive 4. So my b is 4. And my m is -2 over positive 1, right? So from your 4, you're going to go down 2 over 1, down 2 over 1, down 2 over 1. You with me? So do you see where they're going to intersect? Good. Go ahead and draw your line. But do you see how my intercepts actually helped me? Like you could have used that method too. Okay. This area right there, that is your solution. Where they cross. Your solution is an ordered pair. What comes first in the alphabet for it? How do you know which one's first? Yeah, it's your x. This is the x-axis, this is the y, right? So, what is the coordinate for this location? Over 3, down 2. That is the solution. 3, comma, negative 2. That is the only time they will ever intersect. Okay? That's how you solve it with 2 lines. Look familiar? Good. Any questions? If you want to see if you're right, you could go and plug 3 in and see if you get negative 2. Plug 3 into the x. So like on the bottom, if you do 2 times 3, that's 6. And then 6 plus negative 2, that's 4, so it works. You could plug it into both of them. All right, moving on. This one is another example of one solution. What does that mean to you? It's going to cross 1 time. All right. So, are they ready to graph? No. So, you got to do a little bit of work. So, I'm going to give you about 2 minutes to put them both in slope-intercept form. Go ahead and try to do that. Put them both in slope-intercept form. All right, so after we get the first one in slope-intercept form, or let's actually do it, what's the very first thing you do, Cameron? How are you going to put this one right here in slope-intercept form? You're gonna have to move something. How? All right, move the 2x by subtracting. So minus 2x minus 2x. You get y equals. What do you get? Negative 2x minus 1. I like to put my mx in the front. Y'all okay with that? All right, so did you already graph that one or no? Not yet? Okay. Well, we'll go ahead and do the next one. 3y minus 15 equals 3x. Arian, what'd you do? Or what would you do? What's the first thing you'd move? How? All right, move the 15 by adding. Can you actually add them? No. So how are you going to write it? Good. 3y equals 3x plus 15. And then what? Divide everything by 3. Stop. So you get y equals 1x plus 5. So we're going to graph this one, and then we're going to graph this one. Okay? Olivia, where are you going to start on the purple one? Where are you going to graph it? Where does that graph start for this one right here? No. You start at the y-intercept, which is -1. You start at -1. And then from there, Paula, where are you going to go? Okay. Well, wait. Okay, she said she's going to go up to left 1. Is that okay? Why is that okay? Because she made one negative move. That is okay. If you had said you're going to go up to right 1, I was going to be aggravated. So you could go up to left 1, because then your line's still going down. Or you could just go down to right 1. Draw your line. We okay? Alright, Danielle. This one right here. Where are you going to start your graph at?
I start my graph at positive 5.
You're going to go up 5 on the y-axis. So up here at 5, right there. Kinsey, where are you going to go now?
Down one, the left one.
You're going to go down 1, left 1. Down 1, left 1. Down 1, left 1. You see where it's going to cross? Hopefully you do. Okay? Do you see the solution? There's only one solution and it's right here. How do you state the solution? As, yes, it's going to be a coordinate. Check it again. Y'all got -2, comma, positive 3. That's your solution. Done. Easy peasy? Yay. Okay. This one says it's no solution. What could that possibly mean, no solution?
That the problem is unable to make out a solution yet.
But what does that mean to you? I heard someone say it, Kinsey. Yeah, like they're never gonna cross. What kind of lines never cross? Yeah. Parallel lines never cross. So if it's a no solution, it's gonna be parallel lines. I don't mean you graph it on your graph, because this happens sometimes. So this is your graph paper, and you graph one, okay? And then you graph another one, and it looks like this. On your graph, you can't tell me where it crosses, can you?
Can't.
So then people are like, I have people that'll say it's no solution because they can't see where it's crossing. The only time you can put no solution is if it's like if they are actually parallel lines. If you come across this, they're gonna intersect eventually, and honestly, you've done something wrong because I'm not gonna give you one that doesn't cross in the window that we're looking. So you need to redo something. But they will eventually cross. So that's a no. They are going to be parallel lines. And that means they are actually going to be parallel. They will never cross. Does anyone know what parallel means? Yeah, like those lines that go at the same what?
Same
rate?
Rate.
Yeah, they have the same, what do we call that rate? What do we use? The same rate of change. What do we call that? We don't call it, we haven't been calling it rate of change. We've been calling it, no.
Oh.
What does your rate of change represent?
Oh, the gradient.
Your what? Your slope.
Oh.
Your,
gradient.
yeah, they have, in this case they have, I mean we have the same gradient, but it means they have the same slope, but, okay, but, so we're going to write same slope, or should I say same M? Same slope, but they have different something. They have different y-intercepts. Because listen, if they had the same slope and they started at the same place, we wouldn't be on the no solution tab. We'd be on the other tab. So if they have the same slope but they start at different points, it is going to be no solution. So y'all got this?
Yes.
All right, let's go to the next, the actual first problem. Yay, the first one's ready. Okay. Daniela, where are you going to start that one? This one right here. Birthday girl. That's not where you're going to start it. You're going to start at +2 up on the y-axis. If you make sure you hit pin. Okay. And then from there, where will you go? Okay. Good. Down 3, right 1. Down 3, right 1. Draw your line. do not like when it does that. This circle, like, gets stuck. Oh well. All right. Now the next one's not ready. You gotta get in slope intercept form. Alondra, what you gonna do?
You're gonna subtract 3x.
Good. You're gonna subtract 3x to the other side, and you'd be left with what?
Y equals -3x.
If anyone needs to go take a retake picture, this is the last golf retake. This is the last golf retake picture.
Okay, so we got y equals -3x minus 4. Ashley, where's that graph gonna start at? You're gonna start down at -4, and you're gonna go where? I can't go down any. So what would you do if you can't go down?
Up 3 into the left.
Yeah, you go up 3, left 1, up 3, left 1, up 3, left 1. And if you draw your line, they better be better than that one. They should be parallel. And that's not good either. So, if they say, what's the solution for that? You'd have to put no solution. Because they're never going to cross. Alright. Alright, we ready? For the last one? So, infinitely many solutions means you have a line or you have a scenario, okay, and you graph it, and then you're given another scenario that might have different numbers but simplifies to be the exact same line, okay? So it means they have the same slope and the same y-intercept. They're the exact same lines. So we're going to say they're the same lines. So same slope, same y-intercept. Okay, so they have the same slope, same y-intercept. All right, we ready? So like, if you look at these, they don't look like they're the same yet, but maybe after we simplify, they will be. So we're going to take the first one, which is -x plus 2y equals -2. All right, talk to me. Get them in, you want to just get them in slope intercept on your own real quick, so I don't have to go through it? Go. Go ahead, and then I'll go over it. All right, so if you put this one in slope intercept form, I added x. So 2y equals x take away 2. Then you divide everything by 2. You can't really divide that, so just leave it as 1/2 x minus 1. Okay? So then you do -1, go up 1 over 2, up 1 over 2. That's not pretty. Let me do that again. Ooh, nope. Now we're talking. Okay, and then this one over here, all we have to do is get rid of the 4. How? Yeah, you just divide everything by 4. So y equals, what's 2 divided by 4? Where's the mistake that people will make on this one? What are they going to put? Yeah, they're going to put 2. That is not 2. 2 divided by 4, simplified or reduce it down to be 1/2 x minus, what's 4 divided by 4? What's the mistake they'll make for this? 4 over 4. Do y'all know what the most common mistake people make with this? They put what?
1.
No, 1 is right. They put 0. For some reason, they like forget, and they just say, oh, 4 over 4. No, it's 4 divided by 4. Yeah. They must think subtract. Yeah. Okay, so then if you go to graph that, it's going to be right on top of this, right? So the solution is, you can't say where they're crossing. They're crossing everywhere. So the solution for that, they put, I think, I and S on the front of yours. What's the other option that we might say? We called it something else. When we were doing domain and range, we didn't say IMS. It's all real numbers. All real numbers. All real numbers. Yeah, you could use both. You could put if you put IMS, I'll know what you're talking about. Hold on. Okay. We are not going to graph these. We're just going to figure out how many solutions do they have. Do they have one solution, no solution, or infinitely many? So, for example, when you look at this, my slope for the first one is what? Ooh. My slope for the first one is 2. My slope for the second one is -1. How many solutions will this have? 1. Y'all okay with that? They will cross one time. Now, that top one, where would the graph start?
At 0.
Yes, remember that one, if there's no B there, you start at 0? Okay. On this one, what's the slope for the first one? -1. For this one, to put it in slope-intercept form, you would subtract x, so then you get y equals -x plus 3. The slope for that one's -1 as well, right? But is it no solution or is it all real numbers? Why? They're the exact same line, right? So that's all real numbers. All right, this one. Okay, I actually, how many solutions does it have? The slope for the first one is what? 3 over 5. What is the slope for the second one? Okay, the slope for the first one is 3 over 5. The slope for the second one, I want to know, do you know how to graph that? Is that a Bucks or a Hoy? It's a Hoy, and meaning it's a horizontal line at -4. What is the slope for this line right there? 0. The slope for that is 0. You can't say that it doesn't exist. The slope is actually a number, 0. 0. So then it would cross somewhere down there. But, okay. We can't really do these if we don't have graphs, so that's okay. How do you feel? Let's review. Let's go back. How do you know, well, first off, how do you begin? How do you start it? If I give you 2 equations, what's the very first thing you have to do? You got to make sure they are in slope-intercept forms. Good. So once they're in slope-intercept form, then you go to your graph, and what point do you always plug first, or do you graph first? You graph your y-intercept first, right? And then you do your rise over your run. Okay, after you do that for both, then what do you look for? You look where it intersects, right? Anytime you tell me where it intersects, how do you state it? It's a coordinate. And the coordinate is always x, y. X, y. And which one is x? No, not the slope. It's what direction. Yeah, what direction. X is the left-right one, right? And then the y is how far up or down it went. What if they only cross? What if they don't cross? That means the slopes were the same, right? The slopes were the same, but the y-intercepts were different, so they were parallel, right? So that means it was no solution. And then if you get the same exact line, it is all real numbers. They'll be right on top of each other. Good. You don't have any questions? I think you got this. So your assignment that you're going to get is pretty much just this. You're going to work them out on the back. You need to make sure you show your work if you have to put it in slope-intercept form. And then you're going to graph. My recommendation is that you graph in pencil. Okay? okay? Because we don't want to make ugly mistakes on the graph because it's hard to fix those.
Can I glue it now?
Yep, you may glue it in.